Okay, in today's video, we're going to be talking about hydraulic system fundamentals. A little intro. In industrial and mobile fluid power systems, the main sources of energy are hydraulic systems. Hydraulic systems transmit energy by using the energy contained in flowing fluid and converting that energy into mechanical energy. Hydraulic systems can have different components and controls. A fluid power system schematic is used to understand and properly troubleshoot a fluid power system. Properties of liquids. In a hydraulic system, the term fluid usually refers to hydraulic fluid. Most hydraulic fluid is oil-based. A fluid can fill up any container and take the shape of said container. A little side note, a cylinder, also a container, will not operate unless it is full. Liquids are incompressible. The properties of a liquid are determined by the molecules of that liquid. So what's a molecule? A molecule is matter that is composed of atoms and is the smallest particle that a compound can be reduced to, while still possessing the chemical properties of that compound. Molecules are constantly moving. The molecules of a liquid have a semi-strong attraction to each other that allows them to be very close to each other but can still move freely. Unlike air, a liquid is difficult to compress, and unlike a solid, it can be compressed a small amount without destroying its integrity. Principles of fluid flow. What do we know about flow? The standard definition of flow is the movement of fluid through piping in gallons per minute for hydraulic systems and in standard cubic feet per minute in pneumatic systems. Fluid flows from high pressure areas to low pressure areas. Laminar flow is fluid flow that is characterized by a slow, smooth movement of fluid in a straight path along the center line of the passage. Laminar flow is preferred in hydraulic systems because it does not allow unnecessary friction to occur, which achieves minimal energy loss. So remember, laminar flow. Turbulent flow is fluid flow that is characterized by a rapid movement of fluid in an erratic, non-layered, and random pattern. This type of flow causes the velocity of the fluid to increase, which in turn causes inefficiency in a system due to excessive heat buildup because of unnecessary friction. If hydraulic fluid only has one path to flow, that is a series flow path. If hydraulic fluid has two or more paths to flow, that is a parallel flow path. Do we remember what viscosity is? Viscosity is a measurement of the resistance of flow against an established standard. Fluids that are thick and flow with difficulty have high viscosity. Fluids that are thin and flow easily have low viscosity. So for example, water has low viscosity because it'll flow easily. Honey has high viscosity because it's so thick. When hydraulic fluid is heated, viscosity decreases. When it is cooled, viscosity rises. So the relationship between pressure and resistance. Resistance to fluid flow determines the pressure in a hydraulic system. The system is based on the amount of pressure that is required. Resistance to fluid flow is determined by two variables: load on the cylinder and internal resistance of the flow of fluid. Pressure control. Pressure control is important to safety when it comes to hydraulic systems. So if pressure was to build on a system and nothing was in place to correct the pressure increase, the system would fail at its weakest point. To avoid that, valves are used. Relief valves protect the system from overpressure by setting a maximum operating pressure. They are normally closed valves until they sense pressure past their set limit, and then that valve would open up and discharge the excess fluid back to the reservoir. Fluid power system diagrams. There are a few common fluid power diagrams, and those are pictorial, cutaway, and schematic. Pictorial diagrams show where components are roughly located. They show the components of a system in graphic format. Pictorial diagrams can be confusing because they are not standardized, so that means across the spectrum they could be different at any place you work, which means different companies could portray components in different ways. They are not recommended for use for anything other than gathering a general idea of what a system may look like. Cutaway diagrams show the internal details of components and the path of fluid flow. They provide more details of components in the path of fluid flow. For example, a cutaway diagram can show the strainer inside a hydraulic reservoir or a spool inside a directional control valve. They use color coding like how this picture shows. So red would be system operating pressure or highest working pressure, so forth. Schematic diagrams. They use standardized lines, shapes, and symbols to describe a system. These are preferred because they are the most detail-oriented and makes it easier to troubleshoot systems. Also, with them being standardized, they are more likely to remain consistent from job to job. So in summary of this video and what to do next, you need to read over Chapter 3. Make sure you're familiar with the properties of liquids, principles of fluid flow, viscosity, pressure control, and fluid power system diagrams.